This scene deals with the subject many fathers find so difficult.
Welcome to podcast VE 0.1, where we break down the latest research and tools for curious engineers. Today we're diving into a really interesting paper called On Observability and Monitoring of Distributed Systems, an Industry Interview Study. We all know modern distributed systems. Think microservices, cloud-native applications, and the practices often grouped under DevOps are complex beasts. Building them is one challenge. Keeping them running smoothly, performant, and available is quite another. You might assume the biggest hurdles are purely technical: scaling databases, network latency, managing container orchestration. But this study, based on conversations with 28 professionals working directly with these systems across various companies and roles, reveals a significant bottleneck that might surprise you. It turns out, a major issue isn't just the technology itself. It's often about awareness and priorities. Specifically, there's a widespread underestimation of how critical observability really is. And interestingly, this isn't just a management oversight. The study found that even developers frequently don't fully prioritize it, which directly impacts our ability to build and maintain stable services. So let's set the stage. Companies are rapidly adopting paradigms like microservices and cloud architectures. The reasons are compelling: faster development cycles, independent deployments, scalability, and flexibility. We decompose monoliths into smaller services, leverage dynamic cloud infrastructure, and embrace DevOps to streamline delivery. But this architectural shift introduces a new kind of complexity. Instead of one large application, we now manage potentially hundreds of interconnected services, often running in environments where components appear and disappear constantly. Dependencies become intricate, potential failure points multiply, and simply understanding what's happening across the entire system gets incredibly difficult. Traditional monitoring approaches, often designed for more static, monolithic systems, begin to fall short. Knowing if a server is up isn't enough anymore. This is where observability becomes crucial. You've likely heard the term, often linked to the three pillars: logs, metrics, and traces. The paper references its origin in control theory, defining observability as the ability to infer a system's internal state based purely on its external outputs. For us engineers, this means understanding the inner workings of our complex distributed systems by analyzing the data they emit, the logs generated, the performance metrics exposed, and the distributed traces that map a request's journey across multiple services. The researchers argue, and their interviews confirm, that observability is becoming an essential prerequisite. It's not just for troubleshooting when things go wrong, but also for ensuring day-to-day stability and even enabling confident further development. You can't reliably build upon or refactor a system you don't truly understand. To investigate the real-world state of observability, the researchers conducted 28 semi-structured interviews. Think of these as guided conversations, allowing them to explore specific topics while adapting to the interviewee's unique experience. They spoke with a diverse group, including developers, DevOps engineers, site reliability engineers, SREs, architects, product owners, managers, IT operations staff, consultants, and even folks from companies building monitoring tools. They covered various industries like IoT, telecommunications, insurance, and IT services, ranging from small consultancies to large enterprises. This qualitative approach provides rich insights into the actual challenges people face and the practices they employ. The interviews were transcribed and analyzed to identify common themes around challenges, requirements, and solutions. So what were the key findings? The interviews strongly confirmed that a primary challenge is managing the increasing dynamics and complexity inherent in modern systems. As applications become more distributed, utilize cloud services, and perhaps adopt serverless components, the number of moving parts and their interactions explode. A particularly telling example highlighted in the paper concerns configuration management databases, or CMDBs. Traditionally, CMDBs aim to track IT assets and their relationships, but as one interviewee noted, CMDBs often rely on polling, perhaps checking system state weekly. In a dynamic cloud environment where resources are provisioned and decommissioned frequently, a weekly snapshot is far too slow to provide the real-time understanding needed for effective monitoring and debugging. This dynamic nature makes manual tracking infeasible and underscores the inadequacy of older tools and approaches. This challenge isn't limited to new architectures either. The study found that even in older, historically grown systems, a clear overview of service dependencies is often lacking, making troubleshooting difficult. Flowing from this complexity is another challenge: heterogeneity. Today's systems often consist of multiple layers: application code, containers, VMs, serverless functions, underlying cloud infrastructure, frequently managed by different teams using diverse tools. Furthermore, many organizations manage a mix of legacy systems alongside modern microservices, requiring extra tooling and effort to achieve a unified view. The paper also mentions specific issues arising from heterogeneity, like the noisy neighbor effect in multi-tenant systems, where one tenant's resource usage negatively impacts others sharing the same infrastructure, posing a monitoring challenge. However, perhaps the most striking finding is what the paper terms the discrepancy in awareness regarding observability's importance. Despite acknowledging its necessity when directly asked, the interviews revealed that both management and developers often fail to consistently prioritize observability in practice. Why is this so critical? If developers aren't designing for observability from the outset, systems lack proper instrumentation. Features might ship, but debugging becomes painful and slow because the necessary logs, metrics, and traces aren't available. You simply cannot observe what the system doesn't emit. From a management perspective, if the strategic importance isn't fully recognized, observability initiatives might lack adequate funding, time, or focus, being treated as an operational cost rather than a critical enabler for stability and efficient development. This finding suggests the issue isn't necessarily disagreement on whether observability is needed, but a shared tendency across roles to underestimate its continuous importance relative to other pressures, like feature velocity. This leads directly to another major insight. Effective observability isn't purely a technical problem. The researchers identified a strong need for clear organizational concepts. This involves having a defined strategy for observability. Who owns it within the organization? Is there a central platform team? Is it embedded within product teams? Or is it a shared responsibility? Crucially, what are the defined roles and responsibilities related to instrumenting code, maintaining dashboards, configuring alerts, and acting on the insights gained from observability data? The paper emphasizes that merely purchasing sophisticated tools isn't sufficient. Without the right organizational structures, processes, and a culture that genuinely values observability, even the best tools won't yield their full benefits. The interviews indicated that defining these organizational aspects is a significant struggle for many companies. Importantly, while the paper clearly identifies this need based on the interviews, it doesn't detail specific successful organizational models universally adopted by participants. Instead, it frames finding a workable organizational approach as a key challenge companies are actively grappling with, implying the need for a deliberate, context-specific strategy rather than a one-size-fits-all solution. What about the technical side and the tools themselves? While the study's focus was broader, the interviews did touch upon technical challenges. The core issue remains coping with the dynamics and complexity already discussed. Participants expressed a need for tools capable of automatically discovering services and dependencies in these rapidly changing environments, reducing reliance on manual configuration. There's a desire for better ways to achieve transparency into request execution paths across multiple services, particularly when third-party services with opaque internal behaviors are involved. Performance analysis was another area of concern. Often, the true performance characteristics and bottlenecks of the interconnected system only become fully apparent post-deployment, as assessing inter-service dependencies beforehand remains difficult. The paper references related research exploring solutions like automatic behavior model discovery from logs or combining benchmarking with simulation, suggesting these are areas where tooling must continue to evolve. So the study doesn't provide a checklist of missing features, but it reinforces that current tools still face significant challenges in providing seamless, automated, and deeply insightful views into highly dynamic, heterogeneous distributed systems. The demand is for fundamental capabilities to handle scale, complexity, and constant change more effectively. So what's the big takeaway for us as software engineers? This study is a potent reminder that building and operating reliable distributed systems demands more than just writing code and deploying it. Observability, the capability to truly understand our systems from the outside, isn't a mere nice-to-have. It's a fundamental necessity. Achieving it effectively is a socio-technical challenge. Yes, we need the right tools and technical practices, instrumenting our code thoroughly, collecting meaningful metrics, implementing distributed tracing. But equally, perhaps even more critically, we need organizational awareness, a clear strategy, and well-defined responsibilities. The finding that even developers tend to underestimate its importance should prompt reflection. Are we consistently considering how the features we build will be observed in production? Are we prioritizing the inclusion of necessary instrumentation alongside the feature code itself? Are we advocating within our teams and organizations for the time and resources required to build truly observable systems? This study suggests there's room for improvement here. It also underscores that technology alone isn't the answer. We need discussions about strategy and clarity on roles. Does your team have a shared understanding of who is responsible for ensuring your services are observable? Is there a coherent company-wide approach, or is it largely ad hoc? The paper strongly implies that organizations proactively addressing these organizational questions are better positioned to manage their complex systems successfully. Ultimately, this research, grounded in real-world experiences, paints a clear picture. As our systems grow more complex and dynamic, observability evolves from a specialized operational task into a core engineering discipline. It profoundly impacts stability, performance, development velocity, and our capacity to innovate with confidence. Recognizing the awareness gap, particularly within engineering teams, and championing both the technical and organizational shifts needed to enhance observability is vital for navigating the future of distributed systems. It's about more than just logs, metrics, and traces. It's about fundamentally rethinking how we design, build, and manage software.